Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW Gulf. Students, I welcome you all to your Triumph Ultimate batch. Now, you very well know that what are we going to do today? Yes, ma'am, we are going to do the complete recap. But of which chapter, ma'am? Today, we are going to do our P block elements chapter. So I hope so you have heard about the P block element chapter in your class 11th standard, because over there students we used to study about group number 13th and 14th. But what about the rest of the groups? The rest of the groups comes under your class 12th syllabus, that is from group number 15th to group number 18th. Yes, so we are going to cover group number 15 to 18, and also we are going to cover their compounds in this particular session. So I hope so you all are ready for this particular class. Yes, and I hope so that you have revised the previous session also. See students, this Triumph Ultimate Recap session basically is for your revision, for your self-analysis, that whether you know a topic or not. See, in class we do study. We study each and every topic in detail. But what happens is sometimes either due to health issue or some external reasons, we are not able to attend class, or we just lack somewhere. Or sometimes what happen is we are not able to understand, one of the topic. So this sessions like such as the recap session or one shot session that I am giving you over here, or we faculties are providing you over here in the ultimate recap session, will help you a lot. Because if you have not done any of the concept, if you have not attended any of the lectures, but when you're going to do this, no, you are going to revise it completely, right? And also in detail. So students, let us start this particular class with a beautiful smile. Again repeating, this is your Triumph Ultimate Recap. Recap means revision of complete chapter. And if I'm saying it's a recap, it is not going to be like this, we are going to skip any topic. No, not at all. We are going to cover each and every topic in depth. And one more key point I would like to add upon is, students, what happens generally when we, prepare for some competitive exam or for any of the examinations, we don't create any sort of short notes, right? But this sessions basically can help you create short notes or a quick notes type a session where during exams or when the exams are approaching, you can just revise it completely with the help of short tricks or with the help of a short criteria that is being given over here. Yeah, so we are going to cover each and every topic in this particular class. Take out your notebooks, and yes, as you very well know, P block chapter is basically under the inorganic chemistry part. So over here I would request each and every one of you to please take out your NCERT and mark in NCERT only, because that's, that is going to be much more beneficial in comparison to creating one line notes, right? Because in NCERT, if you'll ask me, inorganic is a subject where a complete line is asked, okay, and they ask you that why is it so, what is the reason behind that. You will be seeing over here, I will be letting you know how questions are arising over here in the case of inorganic chemistry. So it's better to take out your chapter NCERT book. If you don't have NCERT book with you, what you can do is you can Google it, NCERT PDF, and you can just download it. It's that simple, right? So let's proceed our today's session with a beautiful smile. The chapter name is P block elements, and we are going to do the complete recap session over here. So what are the today's topic, or what is today's target that we are going to do? This is basically the complete, I would say, this is going to be the complete sequence that is provided to you, how we are going to do it. So the very first part that we are going to start upon is group number 15 elements, students. That is going to be the nitrogen family. As I've already told you, we'll be doing group number 15 to group number 18 in this complete recap session, right? So if I'm talking about group number 15, so it lies under the nitrogen family. Similarly, group number 16 is your oxygen family. Group number 17 basically is your halogen family, and group number 18 is your which family? Is your family of the inert gases. So basically what is going to happen, we are going to cover one by one each and every family and their compounds as well. So we are going to start with 15 group element, and then we are going to see its electronic configuration, its physical properties, its chemical properties, its nitrogen anomalous behavior. Now this is really important. See, what happens is when we study P block elements, we do see that the initial element of all the groups basically holds an anomalous property, anomalous behavior. What is that exactly? We'll be seeing in the class. The next part, students, that we'll be doing is going to be the compounds related to nitrogen family. That is going to be dinitrogen, ammonia, and then the oxides of nitrogen. Now in nitrogen family, we don't only have nitrogen, but yes, we also have phosphorus, arsenic, antimony, and bismuth. So for phosphorus also, we are going to understand the allotropic forms of phosphorus. After that, we'll be seeing the compounds of phosphorus, and then comes the phosphorus halides topic. So this was all about the complete segment of nitrogen in detail. Yes, everyone. The next part that I shall be starting is going to be group number 16 elements. I would say the oxygen family. Now in oxygen family, again the same scenario. We are going to start with general properties, with physical properties, electronic configuration, with chemical properties, with compounds related to oxygen family, such as dioxygen, such as ozone, such as, now as I've already told you, here we have a phosphorus, there we have sulfur, right? So there we have sulfur, refers to as, we don't only have that initial elements compound, we are going to study the other compounds as well. So here we were studying the compounds of nitrogen and of phosphorus. Similarly in oxygen, we shall be studying about oxygen compounds and the compounds of sulfur as well. So initially we'll be covering the oxygen, and then we will be proceeding towards sulfur, sulfuric acid, okay, and then the oxides part as well. Moving on to the next segment, we are going to start with group number 17. That is going to be your halogen family, fluorine, chlorine, bromine, iodine, and all of that stuff. In this also, we are going to move with the same manner, such as electronic configuration, physical properties, chemical properties, the compounds related to that, right? And then in detail, we shall be studying about chlorine. Now, one of the most important segment that many of the students just skip a part, because this chapter is a larger one, is a huge one. So what happen is, they, when they come to an end to this chapter, they just skip this topic. And yes, questions are generally asked from the topic, that is interhalogen compounds. So we are going to cover this at this as well, right? The last segment is going to be your group number 18 elements, very very important one yet again. And yes, in depth we shall be understanding about the noble gases as well. So this is going to be the sequence how we are going to start with our today's session. So yes, students, let's start this particular class with a beautiful smile. Okay, ma'am. So, see students, we are going to start with group number 15. Now over here, students, there shall be some key or major points written over here that you can write down for your short notes making process, or for your NCERT, and you can highlight it over there, right? So starting with the very first segment that I have over here is about your group number 15 elements. Now, group number 15 elements hold which family, ma'am? Hold nitrogen family. What are the elements that are present in group number 15? Okay, the group number 15 elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. So these are the elements that are present in your which group, ma'am? In your nitrogen family. Basically, that is your group number 15 elements. I'm going to tell you each and every characteristic one by one. So the initial characteristic that I'm talking over here is about the metallic character. Let's talk about that. But before that, let's discuss about the electronic configuration of them, right? So if I'm talking about your nitrogen family, that is nitrogen, phosphorus, arsenic, antimony, and bismuth, how you need to remember their atomic number, this is really very important. See, you should know initial elements atomic number. So for that, I can say that if you have a periodic table at home, or if you do know the tricks in order to remember that, please remember at least first 30 elements. Because if you know first 30 elements, then only you will be able to, either guess the other elements, or either you will be able to learn them easily. Now, if I'm talking about first 30 elements, if I'll talk about nitrogen, basically, it has an atomic number, what, ma'am? It has an atomic number 7. Now, if you know the initial elements atomic number, you can clearly identify and tell me the atomic number of other elements. How, ma'am? See, in P block elements, there is a very simple rule for group number 15, from 13 to 17, I would say, not 18. I'm not counting 18, again repeating. What you can do is you can add a number 8, 18, 18, 32. This is basically the magic rule that you have to follow in order to remember the atomic number of these elements. So if I'm starting with 7, I need to add 8. 7 plus 8 comes out to be how much, ma'am? It comes out to be 15. Now 15 plus 18 comes out to be what, ma'am? It comes out to be 33. It comes out to be 33. Now 33 plus 18 comes out to be what, students? It comes out to be 51. It comes out to be 51. I'm writing it again. It comes out to be what, ma'am? 51. 1, because what I'm adding 18 over here, right? Now again, after 51, I'm going to add what? I'm going to add 32 into it. I will get what? 83. So these are the atomic numbers of the elements of your group number 15 family. Very simple part. Okay. Now let's talk about the general electronic configuration, students. If I'm talking about general electronic configuration for nitrogen family, remember it is group number 15th element, right? So general electronic configuration is NS2NP3. What it is, ma'am? NS2NP3. And N basically lies from the value 2 to moving on to 3, 4, 5, 6 and so on as per the period. What is N over here? N over here represents your shell number, I would say, or it represents your period number. What does it represents, ma'am? Shell number, or it represents your period number. Now coming over here, students, see what is going to happen. What is the electronic configuration for nitrogen? If I go with this flow, I know that for the case of nitrogen, N value is going to be what, ma'am? It is going to be 2, ma'am. So what are we going to get? We'll be getting 2s2, 2p3. In phosphorus, what are we going to get? It is going to be 3s2, 3p3. Then in this we are going to get 4s2, 4p3. Here what are we going to get? Here we'll get 5s2, 5p3. And then what are we going to get? We'll get 6s2, 6p3. So this is basically the general electronic configuration of the outermost shell. Now what I refer to as outermost shell, you very well know, but let me repeat it again. See, what is an outermost shell and how to understand this key concept. If I have to write the electronic configuration of my element nitrogen, how I'm going to write it? It is 7. So it is basically 1s2, 2s2 and 2p3. So over here, this one basically, for example, this is nucleus, this is your first shell. The first shell, the 1s shell. And what is the second shell? The second shell is going to be like this. This is the second shell, right? So basically, this is the outermost shell. Second shell is the outermost shell. And second shell contain how many electrons? 2 electrons of S and 3 electrons of P. That means 5 electrons. So in the outermost shell, you will be observing 5 electrons in the case of 15 group element. Let's take an example over here also phosphorus. If you'll see, the outermost electronic configuration is 3s2, 3p3. If you don't know, let us write this as well in order to make it more clear. Phosphorus has an atomic number 15. So how are we going to write, ma'am? It is 1s2. It is 2s2, it is 2p6, how many? 2 plus 2, 4, 4 plus 6 is 10, then comes what? 3s2, 12, then comes 3p3, it becomes 15. So over here, what is the outermost shell? If I have to draw the structure, basically, this is your first shell, students, then comes your second shell, students, and then comes your third shell, students. So this third shell basically is this one. Okay, this 2s2p 6 electrons will lie under the blue region and the 1s2 electrons will lie under the yellow region. So basically you know now that the outermost shell contains how many electrons, ma'am? 5 electrons. So do remember, in the outermost electronic configuration is ns2np3. The value lies from here. N value is 2. Here N value is 3. Here N value is 4. Here N value is 5, here N value is 6. So yet you now basically know what is the electronic configurations. Moving on to the next part, students, we have the metallic character, and let me tell you, the metallic character from top to bottom is going to increase. What is going to happen to metallic character, ma'am? The metallic character from top to bottom is going to increase. That means the non-metallic character is going to decrease. So if I'll talk about the elements over here, do remember nitrogen and phosphorus both are your non-metals over here. They both are your non-metals. Arsenic and antimony both are your metalloids. They both are your metalloids. And if I'll talk about bismuth, it is your metal. It is your metal. So non-metallic character basically is decreasing down the group, but metallic character basically is increasing down the group, if you can clearly observe it. Yes, very simple part. Okay, so let's read some lines over here. Group number 15 includes nitrogen, phosphorus, arsenic, antimony and bismuth. As we go down the group, there is a shift from non-metallic character to the metallic character. So this thing we have already seen, that there is shift from non-metallic character to the metallic character. Okay, nitrogen and phosphorus are non-metals. Now this line we have already done. I have already written over there, but let's read it out. Nitrogen and phosphorus are non-metals. Arsenic and antimony are metalloids, and bismuth is a typical metal. Clear, everyone? That's great. Next is element of nitrogen family are known as pnictogens, and their compounds are called pnictides, as these elements form pungent smelling compounds. Clear? Okay, now let's see the next part, their occurrence. Yes, let's talk about their occurrence, students. Where do they have been seen, or where from where we have got them basically? So the percentage of relative abundance of the elements in the earth crust, if we talk about, is that phosphorus is present in more amount in comparison to the other elements, and then we have nitrogen, arsenic, antimony, and then is basically your bismuth. So except phosphorus, all other elements occur in free state. Yes, in air, N2 occurs to an extent of 78% by volume. Yes, this thing you basically know from the lower classes of yours. Yes, N2 is an essential constituent of proteins and amino acids. Now, this is the just general knowledge sake topic. Now, this topic also we have done the electronic configuration part. I already told you that we have a general electronic configuration of Ns2Np3. Clear? Now, the penultimate shell of nitrogen contains 2 electrons. Penultimate means inner shell, if I'll talk about. Okay, contain 2 electrons. Phosphorus contain 8 electrons, while arsenic, Sb and Bi contains 18 electrons. Okay, let's move on to the next part. Now we have general properties. Very easy part, very easy, interesting segment. If I'll talk about nitrogen, nitrogen is a gas while other elements are solid in nature. So do remember this. Nitrogen is a gas while other elements are solid in nature. I am again speaking that this is a recap session. It is a quick session where you can just revise it if you have notes. And if you don't have notes, you can create it because it is a short revision type of a session where we are covering each and every topic. We are revising each and every topic. So if you have not made notes, if you have not written, if you have not understood, you can do it right now. Yes, everyone? Okay. Now, starting with, I told you nitrogen is a gas while other elements are solid in nature. If moving forward, I would say that arsenic and antimony basically are tetraatomic. Okay, and bismuth is monoatomic. Mono, that means it is a single element, and tetra means it is combining with 4 other atoms, right? So, basically, now nitrogen is a diatomic, that means N2, 2 nitrogen, so it is a diatomic, right? Whereas phosphorus is a tetraatomic again. Now, phosphorus is a tetraatomic solid. Remember, nitrogen is a gas, while other elements are your solid in nature. Now, phosphorus, if it is tetraatomic, what is tetra again? 4, no? So, it is P4. What it is exactly, ma'am? It is P4. What it is exactly? It is N2. Simple part. Nitrogen and phosphorus are non-metals. This we have already done. Arsenic and antimony are metalloids. Bismuth is a metal. Clear, ma'am. Atomic radii. Now, this is basically very, very easy. And see here, they have just given you a general idea, a general way in order to remember that. But yes, I'll tell you in detail. See, students, what happen is, when I'm talking about nitrogen, phosphorus, arsenic, antimony and bismuth, from top to bottom, if I'll see, number of shells are increasing. Now, number of shells, as in here is number of shell is 2, 3, 4, 5, 6. So number of shells when they're increasing, what is happening? See, basically, if this is our center nucleus, first shell, second shell, or let us consider third shell, and here is an electron. So the distance from the nucleus, that means from the center to the outermost shell electron, is basically your radii or the radius, right? So over here, do remember, as you're increasing number of shells, the radius is automatically increasing. So this is what is written. Atomic radii, melting character. Now, sorry, metallic character. Metallic character now only told you it is increasing. Non-metallic character is decreasing, right? And then density, then boiling point gradually increases from nitrogen to what, ma'am? Nitrogen to bismuth, ma'am. Clear, everyone? Easy part. Nitrogen and phosphorus are non-conductors of heat and electricity. Arsenic is a poor conductor of heat and electricity, while antimony and bismuth are the good conductors of heat and electricity. Clear, everyone? Okay, that's great. Let's see, students, the next part of it. Now comes ionization potential. What is ionization energy or ionization potential? What is ionization energy or ionization potential? Let's talk about that. Ionization energy basically is that energy which is required in order to remove an electron from the outermost shell. Yes. So what is an ionization energy? It is basically the minimum energy. It is basically the minimum energy required to remove an electron from the outermost shell. Energy required to remove the electron from the outermost shell of isolated gaseous atom. Of whom, ma'am? Of isolated gaseous atom is your ionization energy. Do remember, ionization energy is directly proportional to nuclear charge, is inversely proportional to size. Always remember this part. Now what happens when we are moving from top to bottom, from nitrogen, phosphorus, arsenic, antimony and bismuth, our basically size is increasing. If size is increasing, very simple, ionization energy will decrease. Why? Because ionization energy is inversely proportional to the size. So basically ionization potential. Now comes what is electronegativity. Very important key concept. What is electronegativity? Electronegativity basically is the tendency to attract shared pair of electron towards itself. The tendency to attract shared pair of electron towards itself is electronegativity. Remember, electronegativity is also inversely proportional to size. If size basically is increasing, electronegativity will decrease. Same trend for electronegativity, it will decrease. Let's talk about electron affinity. It is quite different from all of these terms, but yes, let me explain you. What is electron affinity? Basically, where an electron is added into the outermost shell, the amount of energy released at that spot of time is basically referred to as your electron affinity. Now, what is electron gain enthalpy? Energy given to an electron in order to that it can enter into the outermost shell is electron gain enthalpy. Electron gain enthalpy is just a negative of electron affinity, but both of these terms are almost same, just a difference of a negative sign. That's it, students. So coming over here, it is also going to be decreased, but yes, there is a very small change in electron affinity. Electron affinity has an exception, so I'm mentioning it over here as well. What is that exception, ma'am? See, if we have nitrogen, phosphorus, arsenic, antimony and bismuth, see, electron affinity will also depend upon size, so it is going to decrease. The order should be like this, but it's not like this. Phosphorus has the highest, then nitrogen, then arsenic, then antimony and then bismuth. Okay, yes everyone. Okay, let's see the next part. Melting point increases up to arsenic and then decreases. It is very important part. What very important part? It is due to what? It is due to what? It is due to the lattice energy. It is due to the lattice energy in solids, right? So basically what is going to be the order if you want to write over here for melting point? See, first of all, it is increasing till arsenic, then it is basically decreasing. So if I have to write the correct order, in actual it is like this now, but if I have to write the correct order, nitrogen, phosphorus, arsenic, then basically comes your what? Arsenic, not arsenic, nitrogen, phosphorus, then comes bismuth, then antimony, and at last arsenic. So question from this part is always asked in exam that which of the following has the highest melting point. So the answer is going to be, ma'am, arsenic. Clear everyone? Clear with this part? Just you can put a star over here. See, I am explaining each and every point over here, so it's better if you open up your NCERTs and mention it over there, so it will help you throughout. Let's see the next part. There is a considerable increase in covalent radii from nitrogen to phosphorus. However, from arsenic to bismuth, there is an only slight or a small increase in the covalent radius is observed. This is due to the presence of completely filled d or f orbital in heavier members. So they are saying that yes, atomic radii is going to increase from top to bottom because shells are increasing. But when we come to the lower elements, their atomic radii will increase. No doubt it will increase, but there will be a slight increase, not a much increase, I would say. Not a huge increase, I would say. Let's see the next part, students. Now we have chemical properties with us. Starting with the chemical properties, we have oxidation state. Very important part. Oxidation state, if I talk about the elements that holds general oxidation state over here, is going to be your -3, then it's +3, and then it's +5, everyone. So these are the oxidation states that are exhibited by the nitrogen family elements, if I'll talk about. And yes, what is an oxidation state? The formal charge on any element is basically an oxidation state. And a particular element carries what charge? Is a formal charge, basically, right? So that is an oxidation state. So the group number 15th element are also referred to 5A elements. So they exhibit -3, +3 and +5 oxidation numbers or oxidation state. It is one of the same thing. Nitrogen can exhibit a lot of. Now this question is asked in many exams. In exams this question is asked. They'll give you so many questions, they will give you so many options that nitrogen can exhibit how many oxidation states. So it can exhibit from -3 to +5, to remember. Now, there is much more things about nitrogen, such as the covalency of nitrogen. Many of the students do get confused as they think that it is a member of 15 group family, so it will have a covalency of 5, but no, students, not at all. It has a covalency of 4. Nitrogen is restricted to a maximum covalency of 4, since only 4. That means 1s and 3p orbitals are available for the bonding. That's why. The heavier elements have vacant d orbitals in the outermost shell that can be used for the bonding one. Now, what is the covalency? Covalency, students, if you don't know till yet, you can write it down. It is basically a combining capacity. It is basically a combining capacity of any element. Combining capacity of any element, it's basically its covalency, right? So over here we have said that it has a maximum covalency of what? 4, ma'am. Then if we'll talk about again phosphorus, they are telling that it can form its hydride in the +3 and the +5 oxidation states. And yes, now this is also an important part which I'm going to explain over here. Just see, students, what I'm explaining is a very simple part, but yes, you should know. See, as I've told you, they can exhibit +3 and +5, even -3 oxidation state, but in general, +3 and +5 is exhibited by each and every member. So if I'm going to write it like this, that nitrogen is in +3 oxidation state, phosphorus is in +3 oxidation state, arsenic is in +3 oxidation state, then antimony in +3 oxidation state, and bismuth is in +3 oxidation state. Similarly, can I write for the +5 oxidation state? So I have nitrogen with +5 oxidation state, phosphorus with +5 oxidation state, arsenic with +5 oxidation state, antimony with +5 oxidation state, and bismuth with +5 oxidation state. Do remember this thing, students, when you are moving from top to bottom, the higher oxidation state value basically is going to decrease, and the lower oxidation state value, students, increases. So basically they are stable. Higher oxidation state, when going down the group, becomes the stability basically decreases, while the lower ones have a greater stability if we'll talk about moving down, right? So higher ones are basically stable at the top, and at the lowermost position we have the lower elements. Clear, everyone? Please, students, write each and every key concept that I am mentioning over here so that it is more easy and clear to you all. Done with this one. Higher oxidation state stability will decrease, and in the lower ones basically it will increase down the group. This is due to what? Due to inert pair effect. What is inert pair effect? When the inner electrons won't participate in bonding, that is what is inert pair effect. Clear? Now coming back to this part over here, see, this is what is written over here. The stability of +5 oxidation state decreases and +3 oxidation state increases down the group from to bismuth due to the inert pair effect. Clear, everyone? Moving on to the next part, now we have anomalous property of nitrogen. Now do remember, students, why do nitrogen shows a different kind of a behavior, anomalous behavior? Why? Because nitrogen, in the case of nitrogen, it has only p orbitals. It don't have any d orbitals, so there is no p pi d pi bonding. But yes, in nitrogen it can only do p pi bonding, and it do have a small size, high electronegativity, due to which it shows an anomalous behavior. Let's see. Nitrogen differs from the rest of the members of the group due to its small size, high electronegativity, high ionization energy, and non-availability of vacant d orbitals. Right, everyone? Right. Nitrogen exhibits unique ability to form what, ma'am? To form p pi multiple bond. This is what I was saying. It has a tendency to form p pi bond. It does not make p pi d pi bond, so it has a different property than the other elements, right? So it has an ability to do it with itself and other elements, having the small size of the and the high electronegativity, so it can create bond with that as well. Due to the absence of d orbital, nitrogen covalency is restricted to what? 4, and cannot form what? D pi p pi bond, similar to the heavier elements. Clear? Okay. Now comes the chemical properties, and we are going to start with the reactivity of hydrogens. Now, if I'm talking about reactivity of hydrogens, see how you have to form such compounds. See, remember, here is our element, here is hydrogen. Hydrogen will have, in hydrides, hydrogen has a -1 oxidation state. But over here, we are going to take which kind of a state? A +3 oxidation state. So, what are we going to form? It is basically EH3. Now, E here stands for all the elements, that is NH3, PH3, ASH3, SBH3, BIH3. See, if I'll talk about hybridization, NH3 has sp3 hybridization. Rest other members don't show any kind of hybridization, and even NH3 will show only the bond of the tetrahedral compound, while other elements show an angle of 90 degree over here. Due to Drago's rule, this happens, right? Now, coming back over here, if I'll talk about more of the things over here, when I'm talking about reactivity with hydrogen, the very first question that is generally asked over here is bond dissociation energy. What I'm saying is I'm asking about your bond dissociation enthalpy. So what is the bond dissociation enthalpy basically? This is basically the energy provided in order to break a bond. So energy given in order to break bond, right? That is what is bond dissociation energy. Very simple part. Now, if I'm talking about the lower elements, for example, in NH3, its size is small, so force of attraction is larger. If size is small, force of attraction is stronger and a larger one, so you have to provide a lot of energy in order to break that bond. But if I'll talk about the case of the compounds that are higher, the heavier elements, if their size is larger, students, the distance between the atoms will be larger, right? Force of attraction won't be much stronger in comparison to the atoms that is of a smaller size. So if it has a distance, if you'll provide lower energy only, then also the bond can be broken up. But in the case of that part where we have smaller elements close together which have a strong force of attraction, you have to give a huge amount of energy in order to break that bond, right? So bond dissociation energy, basically it is going to decrease down the group. Yes, everyone, bond dissociation energy will decrease. Now, next part that the question is generally asked is about thermal stability. About what, ma'am? Thermal stability. So what is thermal stability? See, thermal stability is again a word that is used for thermal, for heat, right? Amount of heat given in order to break a bond is thermal stability. So again, the same reason, in the smaller elements, you have to provide a lot of energy in order to break that bond. So you have to give a lot of energy in the comparisons to the one that have a bigger size one, right? So thermal stability is also going to decrease down the group, ma'am, if we'll talk over here. Yeah. Now comes the next part, that is your Lewis basic character. Which topic, ma'am? It comes out to be Lewis basic character. Lewis basic character. So what is Lewis basic character? If I'll talk about in the case of NH3, it has lone pairs only on the nitrogen, but if I'll have the lower parts over there, what is going to happen at that spot of time? The electrons, the lone pair of electrons get diffused when we have a larger elements, when we have elements which has a greater size. But if I'll talk about NH3, PH3, they have a smaller size, so the lone pair of electrons get confined over that. Now, which has a tendency to donate lone pair of electrons? Only, I guess, nitrogen has a tendency to donate lone pair of electrons, right? But other elements would have a tendency. Why? Because the electrons now get diffused up. What happens? Electrons now get diffused up. So will be they able to, I would say that, donate any kind of electrons if they are not able to do? So that means Lewis basic strength is also going to decrease because they won't be able to donate any electrons in the case of higher elements. If they have a higher size, electrons are diffused. If electrons are diffused, how they can donate it? But the elements that don't have the diffused electrons, they can easily donate it. So yes, Lewis basic character also decreases down the group. Let's read about it. All the elements of group number 15 from hydrides of the type H3, where E is basically nitrogen, phosphorus, arsenic, antimony, and bismuth. Hydrides show regular graduation in the properties. The stability of hydride decreases from stability. Now they're saying decreases, right? Which can be observed from their bond dissociation energy. I told you it decreases. Thermal stability, I told you decreases. Consequently, the reducing character increases. Now this is the only part that is increasing. That is reducing character. Okay. Next, ammonia is a mild reducing agent while BaH3 is the strongest reducing agent among all hydride. Basicity also decreases in the order. Basicity also, I told you that it is also decreases, right? Lewis basic character decreases. Let's talk about the reactivity towards oxygen. Now, when I'm talking with regard to oxygen, the elements can either have a +3 oxidation state or elements can have a +5 oxidation state. And when it is reacting with oxygen, oxygen has a -2 oxidation state. So, which types of compound can be seen? See, when elements have +3 oxidation state, oxygen has -2. When we'll cross multiply, what are we going to get? We will get E2O3. What else we are going to get? E having +5 charge, oxygen having -2 charge. So again the cross multiplication, that is E2O5. So that means we are going to form these two types of compounds when there is a reactivity with oxygen. So we are going to form E2O3 and E2O5 compounds over here. E here is the metal. Here they have written M, I have written E. Right. Okay, ma'am. Okay, everybody. Now, everybody, write down. I'm going to tell you what is the acidic one, what is the basic one, and what is the amphoteric one. Yes, everyone. Just write it down. Okay. See, students, initial ones will be N2O3, P2O3, AS2O3, SB2O3, and then we have Bi2O3. So, initial ones are acidic. Initial ones are acidic. And then we have this as amphoteric. And the last one is basic. So this is the nature that you should also know. Clear? Let's see the next one, reactivity towards halogen. Now halogen is X basically. Either it can be fluorine, chlorine, bromine, iodine, which has a negative charge on it, right? So we have in central metal M. It can either have +3 charge or it can either have +5 charge. And X has -1. So what kind of compound can be formed? MX3 or MX5 can be formed. MX3 or MX5 type can be formed. Now let's see. Trihalides are prepared by the reaction of the fifth group elements, that is the nitrogen family, or its compound with the halogens one. NF3 does not undergo hydrolysis, very important. Also, PCl3 is a covalent compound, but the aqueous solution of PCl3 is a good conductor due to the formation of HCl. Clear? Now comes reactivity with metals. Yes, everyone. So what happened? These elements react with metal to form binary compounds exhibiting -3 oxidation state. Let us see an example, that is calcium basically has a +2 charge, nitrogen exhibiting -3 oxidation state when it reacts with metals. So their charges will go at the base, it will be Ca3N2. That is calcium nitride. What it is? Calcium nitride. Similarly, calcium phosphide, sodium arsenide, zinc antimonide, magnesium bismuthide, right? When they are present in a negative oxidation state, so it becomes iodide, and so on. Now students, we are going to start with the compounds of the nitrogen family. We are going to start with the very first, that is dinitrogen, also referred to as N2. Right? Now how it is prepared, there is a table that I have brought over here, a kind of a short summary through which you can learn easily, right everyone? So see the preparation. First of all, it can be prepared by liquefaction and the fractional distillation of the air. Also students, you can prepare it by the laboratory method. If I'll talk about the laboratory method over here, you can prepare your compound. Yes everyone. Everyone, just take a minute, write each and every key concept over here. Write each and every key concept over here. I'll write one more method of preparation till then, everybody. Yeah, so basically it is laboratory method written over here. It is by thermal decomposition of sodium or barium azide. This is barium azide. So when you're going to heat it, it will basically broken into pure barium and the nitrogen. Nitrogen is pure nitrogen. Similarly, sodium azide is NaN3. When you are going to break it, it will break into Na plus N2. Now this is thermal decomposition of ammonium dichromate, NH4 twice Cr2O7. We are going to heat it. You are going to get N2 and you are going to get what? The Cr2O3, the dichromate ion, right over here. Not Cr2O3 is not a dichromate ion, sorry. So you are going to get chromate over here, Cr2O3. Let's see the next one. Now comes the properties part. The N2, if I'll talk about, is colorless, odorless, tasteless, and a non-toxic gas. It is a non-toxic gas. Nitrogen atom has basically two stable isotopes. What are isotopes? If you don't know students, isotopes are something which has the same atomic number but different mass number. Right? Like for example, N14, N15. The next part is it has a very low solubility in water if I'll talk about, and a very low freezing and the boiling point. Next part is N2 is rather inert at a room temperature. Why? Because it has a high bond dissociation energy. Why? Because N2 basically exists like this, N triple bond N, right? So in a triple bond, you have to provide a lot of energy to break that bond. What is bond dissociation energy? The energy provided in order to break that bond. And in case of N2, it is much, much larger, right? So basically, it has a high bond enthalpy. Reactivity, however, increases rapidly with the rise in temperature. Now, there are some reactions that how does that takes place. See, when it reacts with lithium, it forms Li3n. When it reacts with magnesium, it is going to form that. So basically, they have just told you that with some elements it forms ionic nitrides, with some it forms covalent nitrides. Moving on to the next one, it combines with hydrogen and it forms what? Ammonia. Now this basically is also you're going to observe the production of ammonia, where it is a chemical property of N2 in the case of ammonia topic that we are going to do as well, right? Also nitrogen combined, dinitrogen combines with dioxygen to form what? To form basically a compound that is an NO, right? So they are going to form this also. Moving on to the next part. So now comes uses part. See, for providing an inert atmosphere during some electric industrial processes where presence of air or O2 is to be avoided, okay, and for manufacture of ammonia by the Born-Haber's process, that is N2 plus 3H2, basically will give you what? NH3, no? Yes, so yes, for manufacture of HNO3 by the Brundtland-Ide process, and liquid nitrogen is used as a refrigerant to preserve biological materials, food items, and in cryosurgery. Important use. Moving on to the next one now, the preparation of ammonia we are going to start. So we are going to prepare ammonia from the urea. See, now how from the urea? NH2CO, NH2 is basically the urea, right? So ammonia is present in small quantities in air and in soil, whereas so it is formed by the decay of the organic matter urea. You are going to react it water. You are going to get NH4 twice CO3. Then when you are going to heat it, you will get ammonia, CO2 and water. So yes, this is going to be the production of ammonia over here. Moreover, you can obtain ammonia over here from the ammonium salts, right? Which can decompose basically. How? NH4Cl will react with CaOH twice. It will produce ammonia water CO2, CaCl2, sorry. Similarly, if you have NH4 twice SO4 plus NaOH, it will again split into ammonia water and Na2SO4. So these are the production of ammonia and also the Born-Haber's process that now only we have understood in the chemical properties. Moving on to the next reactions, they have given you some more reaction if you want to react it with metal hydrides. Basically, metal hydrides when react with NaOH and water, they are going to produce ammonia. Moreover, we have certain reactions for ammonia, that which of the following are going to react with ammonia and which of the following are not going to react with ammonia. Now coming to the physical properties of ammonia. Physical properties, ammonia basically is a colorless gas with a pungent odor. See, it has a pungent odor, but if you remember in the case of N2, it neither had a smell, odorless, tasteless, colorless, each and everything. But yes, it was non-toxic gas. Over here, if while talking about it is a colorless gas, but it has a pungent odor. Moreover, its freezing melting points are given to you. But yes, students, let me tell you, when I am explaining you about freezing point or melting point and all of this stuff, you need not to learn that. Right? Very simple part. Next is in the solid and the liquid state, it is associated with which kind of a bond? With hydrogen bonds that have a higher melting and a boiling point. So do remember that part as well. It is trigonal pyramidal, okay, and nitrogen atom is present at the apex. It has 3 bond pair and 1 lone pair with sp3 hybridized symmetry, tetrahedral shape. So this is the structure of NH3. Now here comes some kind of a reaction chemical properties that when it reacts with water, it forms its ion NH4 positive and the OH negative. Yes, everyone. And yes, you can learn this part as well, because see what happens is nitrogen in the ammonia act as a Lewis base because it can easily donate its electrons. Yeah, this was I was telling you Lewis basic character also. So there are certain reactions. If you can read it once, that will be easy for you to understand. Yeah. Now comes the uses part. Liquid ammonia is used as a refrigerant for the production of ammonia, fertilizers such as ammonium sulfate, ammonium phosphate, ammonium nitrate, urea, etc. And for the manufacture of HNO3 by the Ostwald process as the laboratory reagent used for rashing process for the manufacturing of hydrazine. Ammonia is oxidized by sodium hypochlorite in the dilute aqueous solution. So these are basically your uses. Now students comes oxides of nitrogen, right? So in oxides of nitrogen we have dinitrogen nitrogen oxide, that is N2O. Then nitrogen monoxide, NO. Now only we have seen a reaction. When N2 plus O2 reacts, it produces nitrogen monoxide. Even it is referred to as nitrogen oxide directly. Then comes nitrogen trioxide, that is N2O3. Then comes nitrogen dioxide, that is NO2. Then is N2O4, that is dinitrogen tetroxide. And at last we have dinitrogen pentoxide, that is N2O5. Clear? Okay, so now these are the reactions, but let me tell you, no need to learn the reactions, just you should know the formulas of them as well and their oxidation state. But yes, reactions, if you'll see it, it will be easy. For example, this reaction is important. For example, this reaction is important. Yes, so if you know that, also you need to know their chemical nature, that which is colorless, which is neutral. So if you'll see, dinitrogen is colorless gas and neutral one. Similarly, if you'll see this one, basically it is acidic and the solid one. So basically it is dinitrogen, trioxide. And this is the brown gas, which one? Nitrogen dioxide. And these kind of questions you should know. Now students, in depth, there is no need to go for the oxides of nitrogen. Oxides of nitrogen in depth, there is no need to do that. Yeah. Yeah. Now comes students your nitric acid, that is HNO3. Nitric acid is also called aqua froth or the strong water. Now if I'll talk about the preparation, so there are two preparation methods by the Ostwald process from ammonia, and then comes the arc process. See, arc process of the Birkeland Island process uses places where electric power is basically cheap, and then we have a principle how we are going to obtain it. N2 will react with O2, it will produce NO, nitrogen monoxide or nitrogen oxide I would say, which further reacts with O2 to give NO2. Now this NO2 further reacts with O2 and water gives HNO3 basically, right? So this is done on the electric arc method where electricity is provided to this. And in Ostwald process, how we are going to do this? Let us see students. In Ostwald process also, you are going to do, as you have seen Ostwald process in the case of the oxygen family also we study about, yeah. So directly you can do in Ostwald process also the production of HNO3. Here comes some of the uses, that in the manufacture of fertilizers like basic calcium nitrite, in the preparation of explosives like TNC, in the preparation of perfumes, Ne3, you can learn it. It will be easy for you to understand. Yes, everyone. And this is the nitration mixture. If you want to read it, you can go through it just for the knowledge sake. Yes. Okay, students, here comes some of the properties. It is a colorless liquid. Laboratory grade nitric acid contains 68% of the HNO3 by mass. Okay, no need to learn the specific gravity value. Concentrated nitric acid is a strong oxidizing agent and attacks most metals except the noble metals such as gold and platinum. Okay, and this is further in detail, no need to go about it, just a general introduction. Now comes the phosphorus and its allotropic form. See, phosphorus and allotropic form, the very first is white phosphorus. How are you going to obtain the preparation method for this? Basically, it is translucent, white, waxy solid. It is poisonous in nature. It is stored underwater. It contains discrete P4 molecules, and it is going to be the structure for the white phosphorus holding 60-degree angle over here in these two phosphorus molecules. Next part is preparation. It is prepared by Ca3PO4 twice. When you react with carbon and SiO2, you are going to get your slag over here, that is CaSiO3, and then you will be obtaining your phosphorus as a byproduct. The next part is in P4 molecule, the 4 atoms are present at the corners of a tetrahedron. I already told you bond angle is 60 degree. White phosphorus molecules has 6 pp bonds. It has a regular tetrahedron structure. It is white due to the bond angle strain, and when it is exposed to air, it will go under oxidation and P4O10 will be formed. It dissolves in boiling NaOH solution and it will produce what? NaH2PO2. NaH2PO2. Clear? Next is about red phosphorus, students. It is obtained by heating white phosphorus. It is obtained by heating white phosphorus for what temperature? Temperature here learning is very important, at 573 Kelvin in an inert atmosphere for several days, students. When red phosphorus is heated under higher pressure, a series of layers of black phosphorus are formed which are similar to graphite. Now, red phosphorus possesses iron gray luster, odorless, non-poisonous. You can just read all the characteristics. It does not glow in the dark. It is less reactive than the white phosphorus. Here comes the black phosphorus. It has two forms, alpha black and the beta black. What? Alpha and the beta. See how alpha black is formed when red phosphorus is heated in a sealed tube, and basically beta is formed by heating white phosphorus as 473 Kelvin. So you need to learn the temperature, because if you heat white phosphorus, you can obtain the previous phosphorus as well. right? The red one. Similarly, for if you're eating white phosphorus, you can obtain the beta black also. Yeah, it does not burn in air up to 673 Kelvin. Now they are saying it is a good conductor of electricity, where alpha black is a non-conductor. So in the form of different students, you can learn all of these. Now this is the structure of black phosphorus, everyone. Here comes the compounds of phosphorus. If I'll talk about the compounds of phosphorus, we have phosphine, that is pH3. What do you have? Phosphine, right? Now, in many of the syllabus of the exams, phosphine is in syllabus, and in many of the cases, it is not in syllabus, right? Phosphine is prepared by the reaction of calcium phosphide, that is Ca3P2, with water. If you'll react it, you will produce phosphine. With HCl, you will produce phosphine. Even phosphine, this reaction is very, very important. Laboratory method is when you'll react P4 with NaOH with water, you will produce phosphine. Next, pure phosphine basically is non-inflammable but becomes inflammable owing to the presence of P2H4 or the vapors. And no need to learn this because this is not generally asked. Properties: colorless gas with a slightly garlic or rotten fish-like smell, highly poisonous, highly poisonous. Slightly soluble in water but soluble in CS2 and other organic solvents, right? The next part is no need to learn for this reaction is not asked, but this, yes, this you should know, right? Even this reaction you should know that it is weakly basic. Uses: the spontaneous combustion of phosphine is made to use in Hummel signals. Containers containing calcium carbide and calcium phosphide are pursed and thrown in a sea. When the gases evolve, burn, they serve as a signal, right? So it can be used in that purposes. Now comes phosphorus allies. There are two kinds of phosphorus allies that you should know, is PX3 and the PX5. That is the PCl3 and the PCl5. And if I'll talk about the oxo acids of phosphorus, students, see, one more thing over here, iodine is not considered over there, we have considered, right? And they will ask you some questions on the stability of the the halides, so you should know that as well. Now students, these are the oxo acids: metaphosphorus acid HPO2, hypophosphorus acid H3PO2, orthophosphoric, see ortho is asked, that is H3PO3. Then basically is orthophosphoric acid H3PO4, or this one. Then comes metaphosphoric acid. Then comes pyrophosphoric, is very, very important, that is H4P2O7, very, very important. Now comes your next group, that is going to be group number 16 students, that comes out to be oxygen family. I hope so you have done the nitrogen family very well. Let's start with oxygen family. Oxygen family includes which element? Oxygen, sulfur, selenium, tellurium and polonium. See, each and everything is going to remain same. Number of shells, if they are increasing, so basically the atomic radii is also going to increase, right? And melting point is also going, sorry, not melting point, I have to write here metallic character. Metallic character is going to also increase down the group, right? And electronegativity is going to decrease down the group. Ionization energy is going to decrease down the group. Each and everything in the previous case as we have done is similar to this as the general properties. See, oxygen, sulfur, selenium, tellurium and polonium are the elements of the 16th group elements, okay? And the first four elements are collectively known as chalcogens or the ore forming elements, right? I guess you have heard this term in metallurgy chapter as well. Now the next part is, since many metals occur as oxides and sulfides in nature, the elements belong to p block since the differentiating electron enters into the p electrons. Now the general electronic configuration is NS2NP4. Nitrogen family has NS2NP3, they have NS2NP4, everyone. The next part, if I'll talk about their occurrence, so the occurrence of the chalcogen family is basically oxygen, sulfur, selenium, tellurium and polonium. Oxygen is the most abundant element in the Earth's crust. It constitutes 46.6% of the Earth's crust and 21% of the air, this you very well know, and 89% of the oceans by weight. Let's talk about the physical properties. See, oxygen basically is a gas while other elements are solid. Similar to the nitrogen family, it is quite same things. In oxygen molecule, strong double bond is present, so it exists in isolated molecule, that is in the form of gaseous one. Atomic weight will increase down the group. Remember that atomic size is increasing. Ionization energy, electron negativity decreases, already told you. And yes, one more thing, for electron affinity, very important part. See, the trend should be oxygen, sulfur, selenium, tellurium and polonium. Down the group, electron affinity should also decrease. This should be the order, but this is not. See, in the case of nitrogen, it came after phosphorus, but over here oxygen will have the least value. So the order is going to be sulfur will have highest, then selenium, then tellurium, then polonium, and at last it is going to be oxygen. At last it is going to be oxygen atom. Density increases from oxygen to polonium. Melting point and boiling point basically changes regularly. So this is going to be the order for that. Now electronic configuration, if I'll talk about, I already told you NS2NP4, that means 2 of S and 4 of P, that means 6 electrons in the outermost shell, right? And the penultimate shell contains 2 electrons in oxygen and the stuff. Now what is cationation capacity? Oxygen and sulfur forms the cationation capacity. Cationation is maximum in sulfur up to the 10 atoms, and in case of oxygen it is limited to 2 atoms only. Self-linkage properties, right? Oxidation state, what I'll talk about over here, the oxidation state, ma'am. See here they exhibit +4 and +6 oxidation state in general. Right, so the common oxidation state of these elements is -2 because they have NS2NP4 configuration. They can have -2 as well. Oxygen show positive oxidation states in the case of fluorides. For example, if you have O2F2, OF2, you can calculate. For example, it is O2F2. See, for oxygen, you can say 2x. Now, for fluorine, you know it's -1. There are 2 fluorine. Overall sum is 2. 0, sorry. 2x is equals to 2. X is basically your +1, right? In OF2, if I'll talk about again, x plus fluorine is -1. There are 2 fluorine is equivalent to 0. X minus 2 is equivalent to 0. X over here is +2. Very simple thing, right? The oxidation state of oxygen peroxide is -1 and in superoxide is -2. So do remember that. Oxygen cannot exhibit the oxidation number beyond +2. Always remember, in general, oxygen can have -2. In general, it is -2. In general, it is -2. Now, other elements can show -2, +2, +4, +6 due to the availability of the d orbitals present over there. Possible oxidation state of sulfur in ground state is -2 or +2. Clear? Now, anomalous behavior just similar to the nitrogen. Basically, it has a small size, high electronegativity. Okay, and then we can say it does not have any orbitals present over there. That's why. So it is due to small size, high electronegativity. Oxygen possesses the anomalous behavior. Oxygen forms hydrogen bond in water, right, which cannot be seen in the case of H2S. So this is important part. Now hydrides reactivity with hydrogen, it is same as that we have done in nitrogen family. So not writing it again. Same again repeating, same as of nitrogen family. Just create the compounds and then you can tell what is the order of bond dissociation energy. It will decrease. What is the order of Lewis basic character? It will decrease. What is the order of thermal stability? It will decrease. What is the order of reducing character? It will increase, right? So the same orders. Next come reactivity with oxygen. See, when they are going to react with oxygen. See, oxygen reacting with oxygen. Yeah, so it's very simple. Yeah, very easy part, no? See, basically, either they can form dioxides or trioxides. When they're forming dioxides, it's SO2, SeO2, TeO2. When they form trioxides, even O3 is an example over here. It's not in this one. In the above one, O3 is an example over here. SO3, SeO3, TeO3. Here, O3 is also an example, right? Moving on to the next one, see, SO2 is a gas, SeO2 is a volatile solid, and TeO2 is a white non-volatile solid, right? And similarly, SO2 is angular, where sulfur can exhibit sp2 hybridization over there. So this is the order of acidic strength they have given you. This is the order of acidic strength, students. In the case of trioxides and in the case of dioxides, right? And POO2 is basic. SO3 is more acidic than SO2. Now, when we'll talk about halogens, that is creating bond with fluorine, chlorine, bromine, and iodine. It is also similar to that of nitrogen family, just as we have done over there. Same occurs over here. They are going to form which type of a compound? Either EX6, EX4, EX2. Because here the elements will have either +2, +4 or +6 oxidation state. Halogen has -1, so they can form EX2, EX4, EX6 compounds. Clear, everyone? The stability of the halides basically is going to decrease. Clear? Now comes the very first compound, that is dioxygen. Dioxygen, that means O2. See, they are saying that it differs from the remaining elements by the 3 properties: small size, high electronegativity, and non-availability of d orbital, just as nitrogen had. Preparation for this is very simple by the thermal decomposition of oxides of metals. If you're going to decompose them, you're going to get the pure O2. Clear, everyone? Pure dioxygen. There are more reactions. Now, this reaction is very, very important. You can put 3 stars, 5 stars. By thermal decomposition of oxygen-rich compounds, KClO3 when heated will give you KCl plus O2. H2O2 when heated will give you H2O plus O2. Hydrogen peroxide, right? And industrial methods are also there. Industrial methods also you can apply. Then comes physical properties. It is colorless, odorless, tasteless gas. It is paramagnetic, exhibits allotropy. It has these isotopic forms, and then it does not burn because it is a strong supporter of combustion. Uses in welding and cutting, oxyhydrogen or oxyacetylene torch is used. Any of the two uses you can learn. It is used as a fuel in rockets. Yes, everyone. Now comes the ozone part. Ozone basically is O3. It is an allotropic form of oxygen. And about ozone, you have understood in biology, though, so I'm not explaining that concept. What is ozone? How it is protecting? What is the role of it, right, in the atmosphere? Coming to preparation, how you have to prepare it is by silent electric discharged method, right? So basically, this is the production of O3. O2 will split into the nascent oxygen and then it will react with O2 again, forming O3. The product is known as oxidized oxygen, right? Oxidized oxygen. Moving on to the properties, it is pale blue gas, very important. Many of the students even don't know about it because it forms a blue liquid. On the solidification forms, violet black crystals. It has a strong fish-like smell. It is slightly soluble in water, but yes, in other ones they are telling you how much it is soluble. O3 molecule is diamagnetic. O3 negative is paramagnetic in nature. This you have done, I guess, in molecular orbital theory also. Uses of ozone, basically it is used as a germicide and a disinfectant, used in improving the quality of atmosphere at the crowded places, used for bleaching oils, oil paintings, ivory and all of that stuff. These are the uses of that. Now comes the sulfur. Sulfur, basically we're going to do the allotropic form. It has 4 allotropic form: alpha, beta, then we have gamma. Here is beta, will come alpha, beta, gamma. Okay, and then zeta. Alpha, beta, gamma forms of sulfur are crystalline in nature and possesses the puckered ring-like structure. Plastic sulfur is also one of the form which many of the students not have even understood about it. Compounds, if I'll talk about a structure of SO2. SO2 basically over here has a bend shape, you can clearly observe. Sulfur is sp2 hybridized. It is an angular molecule with a lone pair on the s orbital. It has 2 resonating structures, right? Now, if I'll talk about the preparation, in the preparation method, you can learn this reaction. Sulfur, basically, if I'll talk about sulfur dioxide, is formed by reacting sulfur and oxygen, right? Sulfur in the presence of air, and also you can learn any of the 2 reactions of the preparation method. Moving on to sulfuric acid, students, it is very important chemical that is used in the industry. It is also referred to as what? Oil of vitriol, or the king of chemicals. King of chemicals, sulfuric acid. How do you obtain that? H2SO4 by lead chamber process. How? See, sulfur when reacts with oxygen in the presence of air gives SO2, right? So basically they have given you so many reactions that you can further react with NO2 or with water. You are going to obtain with water, that is going to be H2SO4. How? Because see, first of all, SO2 reacts with NO2 gives SO3. This SO3 will further react with water to give H2SO4, right? So this is the production. And even if you want to read more instructions about it, it is clearly mentioned that nitric oxide produced takes oxygen from air and gets converted back into nitrogen dioxide. Okay, this can again take it and convert back into NO2. Do remember this. Okay, see this. NO reacts with O2 again to form NO2. It can convert back into NO2, right? Clear, everyone? Now students, come the contact process. See, in contact process there are various methods in order to do the production of that as well. So in this, basically the third and the fourth reaction is really very important, because in exams they are going to ask you what is the formula of oleum. So if you know the formula of oleum, you can clearly tell me. See, what is the in contact process? First of all, there is a burning of sulfur or the sulfide ores, that is S plus O2 gives SO2. Okay, and if SO2 produced, will further react with O2 to give SO3 in the presence of V2O5, and this SO3 will further react with H2SO4, will give you oleum, H2S2O7, which on further reaction with water will give you your product, that is H2SO4. Clear, everyone? Now we have a physical property that they are a colorless, it is dense, oily liquid. Melting point, no need to learn it, but yes, you should know. They have a high boiling point because yes, it can form hydrogen bonding again over here. Yeah. Chemical properties, if I'll talk about, it is due to low volatility, strong acidic character, strong affinity for water, can form hydrogen bonds, act as an oxidizing agent. Okay, so this is about the chemical properties. It reacts with metal halides to form what? metal halides to form hydrogen halide and M2SO4, right? It is a very good dehydrating agent, students. It removes water from carbohydrates. Hot concentrated H2SO4 is moderately strong oxidizing agent. So some of the reaction for oxidizing agent, these two reactions are important. You can mark it, learn it. Uses, it is extensively used in petroleum refining in detergent industry. Clear, everyone? Everybody please write it down. Till then I'll drink a glass of water, please. Yes, I hope so. Everyone has done with this part. Now we are going to start with group number 17 and then the 18. Starting with group number 17 elements, I know students, you may feel like ma'am is running, but understand my key point. I have mentioned each and every point over here so that you can revise it. It is a recap session, a quick review either in 1 hour or 1.5 hours, right? A quick revision. So if you have understood the chapter, it is a, you know, a fastest revision, I would say, for you people. Yeah. And if you're not getting it, that means you have to understand the topic in detail. So this is a self-analysis, again repeating. Yeah. Starting with halogen family, we have fluorine, chlorine, bromine, iodine. Yes, these are the halogen atoms. Halogen means salt producing elements. They occur in the combined form. For example, F2Cl2, Br2I2. This is a combined form, right? Now, occurrence of the elements in the form of compounds is called the combined state. Acetylene is a radioactive element. Okay, already mentioned. Common oxidation state, now only we are creating compounds. It is -1, ma'am. What it is? It is -1, ma'am. Yes, everyone. Is it -1? Okay. Now, an acid in which central metal is bonded with hydroxyl group containing acidic hydrogen is oxoacid and oxyacid. Right? Let's talk about the interhalogen compounds. When halogen and halogen are combining with each other, they form interhalogen. So there are some characteristics which electronegativity, based upon the electronegativity, which element will come first, higher one or the lower one? We'll come to that point. Let's talk about the occurrence. Now they are very reactive non-metals, I would say. They don't occur in the free state, they occur in the combined state. Do remember that. Now they are some of the examples they have given you. Comes to the melting point and the boiling point. So basically it increases from fluorine to iodine due to increase in the van der Waals forces. I2 sublimines on heating without, the melting at ordinary atmospheric pressure. And non-metallic nature basically is going to decrease over here. Do remember that metallic nature will increase. Ionization potential, if I'll talk about, of halogens are very, very high. Ionization energy order is almost same, because what happens, it is inversely proportional to the size. As you are increasing down the group, size increasing, ionization energy will decrease. But if I'll talk about with regard to the other part, other elements, they have a higher one. See, it decreases from fluorine to chlorine because increase in atomic size. Yeah. Okay, next part about solubility. They are soluble in water, which follows the order. F2 is more soluble than Cl2, then Br2, then I2. Physical properties, if I'll talk about, they exist as a diatomic. I already told you, right? They have van der Waals forces of attraction. The only type of attraction between the halogen molecules is this. Fluorine and chlorine are gases. Bromine is liquid and iodine is solid at room temperature. This is important key concept. Atomic radii will increase because number of shells are increasing down the group. All halogens are colored. By absorbing different quanta of radiation, they display different colors. F2 will exhibit yellow color, Cl2 will exhibit greenish yellow color, Br2 will exhibit red color, I2 will exhibit violet color. Simple part. Starting with the chemical properties, now we have again the oxidation state over here. See, all of the elements except fluorine can exhibit which kind of oxidation state? -1, +1, +3, +5, +7. Fluorine will always exhibit -1 oxidation state. Do remember that. Again, the same part. Higher oxidation state value is going to decrease. Lower oxidation state value is going to increase as you are going down the group. Let's talk about chemical reactivity. F2 will be more reactive than Cl2, then Br2, then I2. This is going to be the order because halogens are highly reactive in nature. When do they reaction with water? Halogens are sparingly soluble in water because they are non-polar covalent molecules. So the solubility of halogen will decrease from F2 to I2. And yes, here you can see how they decompose water to liberate a gaseous mixture. So basically these are the reactions. Right? Now it is an important reaction. Chlorine basically reacts with water and forms HCl and HOCl. Chlorine acts as a bleaching agent in the presence of water due to formation of HOCl in it. So it is very important reaction. Let's see the reactivity towards oxygen. Now when they are reacting with oxygen, it can form fluorides basically, O2F2, OF2, these kinds of compounds. OF2 is thermally stable, this you should know. Chlorine oxides are also formed such as Cl2O, ClO2, Cl2O6, Cl2O7. Remember, fluorine can always show -1. Chlorine can exhibit -1, +1, +3, +5, +7. So they can form different compounds as per that. And you can always remember that chlorine can act as a bleaching agent also, so that also you can do. Now when they react with hydrogen, they form hydrides, very simple, right? H2 plus H2 will give HF, H2 plus Cl2 will give HCl, it will give HBr, it will give HI, right? Simple, easy reactions. Now the reaction with iodine, they are saying it's irreversible. Sorry, it's reversible. How they are saying is the reactivity of halogen with hydrogen decreases from F2 to I2. This we very well know, students. The stability also decreases, if we'll see over here, okay, of the hydrides. Now reaction with NH3, it can react with NH3. For example, F2 can react with NH3, it can give HF plus NF3. Here excess of fluorine is used. When limited fluorine is used, it will give you dinitrogen. Remember that. Now with alkalis, that means with NaOH also it can react. F2 can react with NaOH. Okay, when it react with cold and dilute NaOH, it will give NaF, H2 and OF2. Okay, but if it is reacting with hot one, it will get NaF, H2 plus O2. Here O2 will be produced, here OF2 will be produced. Similarly, they have given you certain reactions for Cl2, Br2 and I2. This is for the state of cold one and this is for the state of the, hot and concentrated one, right? So you can obtain that different products are obtained over here. This, clear? Now with metals, they can form metal halides, very simple, students. Coming to the very first compound, we have chlorine with us. Now chlorine basically, that is Cl2. What is chlorine? It exists in diatomic form Cl2. How you can prepare it? Very, very important reaction. When MnO2 reacts with HCl, it will produce MnCl2 plus Cl2. Very, very important again speaking. This is also again important. KMnO4 plus HCl will give you KCl plus MnCl2 plus Cl2 plus water. Again, one more, Deccan's process is an important one. Deccan's process in HCl plus O2 will give you Cl2 plus water. Electrolytic process, this is not that important, but yes, if you should know that in electrolytic process, here we are going to do the electrolysis, that is anode and the cathodic reaction. Yes. Then comes properties. It is greenish yellow gas with pungent and suffocating odor. Okay, it is heavier than the air if I'll talk about. When it reacts with metals, it will form AlCl3. For example, if it reacts with Fe, it will form FeCl3. It will react with non-metal, for example, P4, it will form PCl3. It will react with sulfur, it will form S2Cl2. Right? Now reaction with NaOH, it can form NaCl and NaClO. This reaction was given in the previous page also. Similarly, with dry slaked lime, it can produce, okay, CaCl2 as a product, and the composition of bleaching powder is also given to you. Now comes your hydrochloric acid. This is hydrochloric acid, HCl. Okay, so HCl can be prepared by various ways. These two are important. NaHSO4 plus NaCl gives Na2SO4 plus HCl. Properties, it is colorless, it is pungent smelling gas. It can be easily liquefied to colorless liquid, students. Okay. And now comes the most important part, that is interhalogen compounds. Interhalogen compounds is when one halogen is combining with another halogen atom. We know that halogen atoms have different electronegativities, right? Due to their difference in electronegativities, the halogen atoms combine with each other and give rise to the formation of binary covalent compounds, which are referred to as interhalogen compounds. Yes, so there are some examples. All of these reactions are important, students. For example, Cl2 plus F2, equal volume if we'll take, you will form ClF. Higher electronegativity is written at the end, lower at the first. Similarly, Cl2 plus F2 in excess is ClF3. Now, I2 and Cl2. Yes, I2 and Cl2. So, Cl over here, I over here. Now, this is equimolar. When it is diluted with water, Br2 plus F2, F will be written over there, high electronegativity, lower over here. High over there, lower over there. Diluted with I2, so I2 plus F2 will give you this, right? Similarly, Br2 plus F2 in excess will give you F5, sorry. Properties, these compounds may be gases, liquids or solid. Gases, they have given you which are gases, which are solid and which are liquid in nature, right? Or interhalogen compounds are covalent molecules and are diamagnetic in nature, students, right? And the boiling point increases with the increase in electronegativity difference between both A and B compounds forming together. Interhalogen compounds are more reactive than the parent halogen but less reactive than F2. Remember that. Now, these are the hydrolysis reaction that they have given you. When they are going to hydrolyze, it will form HB and HOA, right? For example, BrCl will react with water, it will form HCl and HOBr. H and A. H and A, the very first one will be written at the end. Similarly, HiO2 will be formed, right? Now comes the last part, that is group number 18 elements, that is the noble gases. Basically, helium, neon, argon, krypton, xenon, all lies under this basically. These are known as noble gases. Their atomic numbers basically are 2, 10, 18, 36, 54 and 86 respectively. Number of valence electrons in helium is 2, while the valence electrons, outermost shell electrons, will be 8. Physical properties, they are monoatomic, they are colorless, they are tasteless, they are sparingly soluble in water. They have a very low melting and a boiling point, right everyone? Helium has the lowest boiling point, and here we have weak dispersive forces. Do remember that. Moving on to the chemical properties over here, noble gases are least reactive. When you move from top to bottom, the size will increase. Very simple part, number of shells are increasing. So these are the very key concepts that yes, you should know about this as well, right? Noble gases except helium have completely filled electronic configuration of Ns2, Np6 and all that stuff, but helium has only one NS2 part, right? High ionization enthalpy, more positive electron gain enthalpy over here, right? No need to read about it, no need to do that. Now comes the compounds of xenon. The very first is xenon fluorine compounds. Xenon fluorine compounds, when we have 2:1 XeF2, it will form XeF2, right? And it is soluble in water this is the chemical reactions. XeF2 when reacts with H positive an electron, it will give Xe plus HF. When it reacts with H2, it will give HF plus xenon. Now, this is hydrolysis in water is very slow. It will hydrolyze slowly. It will give you Xe plus HF plus O2. It can act as a fluoride ion donor as well. Yes, xenon fluorine 1. So yes, students, now we are ending our today's session over here. I hope so. You have completed the complete session over here. Again repeating, it was an ultimate recap session. So we just revised each and every topic, but yes, in a quicker manner. If you feel that, I was running fast, that means my voice was fast, so you can slow that with the help of the settings option given you over there on the YouTube itself. So you can slow it down, you can see at a slower speed. But yes, it was a recap session, so yes, we need to cover each and every topic though. So I tried to complete each and every topic, but yes, you can read the NCERT, you can complete it from there as well, and you can even mark the importance key point which I have written over there, so that it will help you out a lot. Yes, students, now I shall be meeting you in the next class. Till then, keep smiling, keep learning. Thank you so much and take care of yourselves. Thank you so much, students.